Hi everyone. In this video, we're going to focus on lumber. Let's start with the obvious. Lumber comes from trees. All right. So trees are cut down and they are brought to a sawmill. Those logs are then cut into different types of lumber. Here's an example here. We can kind of see the growth rings of a tree and the different ways that those might be cut into boards. All right. And so it's really important as a designer that we choose sustainably grown lumber. One way to do that is to choose FSC labeled products. Those logs come into the lumber mill and they are cut, dried, and milled until the lumber is at its final dressed size or actual size. And it turns out that that actual size is smaller than the nominal size. This is confusing for all sorts of beginning students, right? So the actual size is what your piece of lumber would measure with a ruler, right? If we held a ruler up to it, that's what it would measure. The nominal size, I like to think of it like a nickname. We call it by this name in casual conversation. Right? And if you write it, don't use inch symbols. As a designer, be sure to draw your details using the actual size. We want to account for the actual size of the member, right? But then label them with that nickname, with that nominal size. So an example here is that a 2x4 actually measures 1.5 inches by 3.5 inches. Notice that when I wrote this 2x4, right, there are no inch symbols. But when I write the actual size, 1.5 inches by 3.5 inches, right, we use those inch symbols. How do you remember this? Do you memorize every different size? No. I mean, you can, but no. There is a shortcut, all right, to help us out. And starting with a nominal dimension of 1, which is pretty thin, all right, the dressed size is 3/4 of an inch, or you can think of it as subtracting 1/4 of an inch. All right, so the dressed size or actual size is a little bit smaller. If your nominal dimension is 2, 4, or 6, all right, you're going to subtract 1/2 inch. Meaning, for example, this nominal size of 4, like in our 2x4, you're going to subtract 1/2 inch, you're going to get 3.5 inches. Right? Anything larger than that, 8, 10, 12, etc. All right, you could go bigger, but you don't usually. You're going to subtract 3/4 of an inch. So, for example, a 10 of a nominal dimension, subtract 3/4 of an inch. What's the actual dimension? All right, if you just said 9.25 inches, I think you've got the idea. Next, let's look at some engineered lumber, starting with the sheet products. So engineered lumber or engineered wood products have additional work done to the wood, all right, in between the forest, basically, and your house. All right, so they're not just lumber. They've had more processing. Okay? And plywood and OSB are some really common engineered wood sheet products. They're both used for structural sheathing and subfloors. Taking a look at plywood over here, plywood is made of layers of veneers. And as those layers are put down, the grain alternates. All right, so it's very strong and stiff because of that alternation. Right? Plywood is graded based on the appearance of the face veneers, all right, kind of sandwiching at the top and the bottom. And so you can get plywood that looks better than others, if you need be. Moving to the right, we have OSB, which stands for Oriented Strand Board. It's made of wood chips or wood strands, and they're pressed together with a binder. Right? OSB is less expensive than plywood. Right? But it's more susceptible to moisture damage. So anywhere where there's a possibility of moisture, you want to use the plywood. All right. But if it's totally inside the home within that building envelope, you can use OSB. Our next engineered wood product are engineered joists. These can be called I-joists. You can see why their shape right here. Or another common name is TJI, right, which is kind of a brand name for them. And these engineered joists are lighter and more stable than your typical lumber, and they will span longer distances. They are more expensive individually. So if you're going to buy a floor joist versus a engineered joist, the engineered joist is going to be more expensive. But often the entire system is more economical to build using the engineered joists because you can build less of them. Right? You can buy less of them, excuse me. Our last engineered wood product are prefabricated trusses. Now these are individual pieces of lumber, right? You can see them put together, prefabricated at the factory to create these trusses. And they can be used for floors. So you can see these very flat trusses would create a flat floor surface, right? Or they can be used for roofs, and they're often peaked like this for the roofs, right? Prefabricated trusses are great for wider spans. You can have a longer span than a typical floor joist or roof rafter, and they are easier to construct on site because they're prefab. Thanks everyone. In this video, you've just learned about lumber and engineered wood products.